Cyclic hydrocarbons. So everything we've been dealing with so far are hydrocarbons. I hope it's obvious to everybody that the name hydrocarbon means hydrogen and carbon, right? So the ends are connected. Really all you gotta know. We're taking our alkanes or alkenes or alcohols, wherever they are, we're taking the two ends and sticking them together. Whenever you connect the two ends, you have an extra bond there for the two end carbons, so you lose the two hydrogens on the end. So the formulas are gonna have two less hydrogens than they normally would. So let's just draw some stuff here. Let's do cyclopropane. Let's do that. So this is propane, where we're taking the two end carbons and we're sticking them together. So what that's going to look like is, normally propane has three carbons in a straight line. So here, they're going to connect together like a triangle. Because there's three of them, it has to be a triangle, right? And then each one's going to get two hydrogens. This would be normal propane. So basically take a hydrogen, take another hydrogen somewhere along with the bond. I should use the other one. And then you just stick the two ends together. And there's cyclopropane.
You should practice doing that because that looks pretty cool.
Every day, all day long. That's what I do on my weekends. Alright, cyclobutane. Oh, should I write the formula here? I should, right? Because I want you guys to know. What's the formula here?
H6.
So, if it's an alkane and it's cyclo, yeah. Because remember, for the regular alkanes, it was 2N plus 2. You connect the two N carbons, you lose those two hydrogens, so it's just 2N, double number of carbons. Alright, cyclobutane. So if it's 4, it's going to make a square basically, right? The rest of them will look more like a ring, but the small ones look like shapes. And then every carbon gets two hydrogens again, so. C4H8. So I can make this one for you if you want. This will be. Guess I should have practiced doing this one. There we go. Okay. So that's cyclobutane. I'll use the small one up here so it looks kind of screwed up. Shouldn't be like that. And let's do cyclopentane. So what kind of shape do you think this will have? Kind of gun. Pentane. Yep. And these pentanes and hexanes and enes and O-holes and stuff, you'll see them a lot, 5 and 6 sided shapes. Ribose sugar, which is the sugar that's in RNA, it's a 5-point ring. I think one of the points is an oxygen with 4 carbons. There's lots of other shits, ones that you'll see like that. It'll be like bigger molecules with like a pentane or hexane. Alright, so that's cyclopentane. And I said a cyclohexane would be a hexagon with 6 carbons in a ring, and so on and so forth. Formula C5H10. All right, so we can use, we can have cyclic alkenes and alcohols also, right? And then we would use numbering system to denote where the oxygen is or where the double bond is, same as we did with the other ones. When we have a ring, obviously if there's one double bond, it's going to be one, what would it be, cyclohexene or whatever. It's going to be number 1 because wherever that first thing is, you're going to call that 1. So for anything that has either one double bond, one oxygen, it's just going to be number 1. So I'll show you what I mean here so that makes some sense. Let's say we have, let me draw it first, then we'll name it. Okay, so we'll make cyclohexene, and we'll make it with only one double bond. Okay? And let's fill in all the carbons, the hydrogens really. Do one up here, one over here, 2. Make sure you count the bonds on the carbons, right? This one already had 3, so it only gets 1 hydrogen.
Wait, what's this?
This, well, this is going to be cyclohexene, but it's going to need a number also. So we'll talk in a second about what that is. Let's go ahead and draw it first. I need more coffee. All right.
So how come all these are getting more?
What's
Wait.
that?
How come the first 2 are getting more?
Why are they getting 1? Look at this carbon. 1, 2, 3 bonds. That's the 4th one.
Okay.
Right, everybody sees that, right? 1, 2, 3. So you can only have 1 hydrogen. Make sure every carbon you do that when you're drawing this yourself. Look at each carbon, it can only have 4 bonds. All right, so if we were to name this, you see it goes in a circle, right? You see the ends are connected. It's not a chain. It's not just a long chain. So it's cyclo. So that part's easy for you to figure out. This is obviously cyclic. If you count the carbons, there's 6 of them. So you say hex, right? All this stuff you know. And then you see double bond right there. That double bond tells you it's got to be ene, E-N-E. But we need to denote the position of the double bond. When there's 1, you just make that the first carbon. 1, 2, 3, 4, 5, 6. So it's going to be 1 cyclohexene. So anytime there's just a single double bond or a single oxygen, it's going to be number 1 at the beginning. So really, it's kind of like pointless if you only have one thing on there to number it. But when we get to 2 or 3, the numbering starts to make sense. So let's draw one with more than one double bond, and then see how we can number that. So let's do
What's the equation for that though?
the equation. Let's see, 1, 2, 3, 4, 5, 6. C6. 1, 2, 4, 6, 8, 10. C6H10. All right. So for this one, there we go. All right, so from here, we can start with either double bond. So we're going to start up here, 1, and then I'm going to count this way because it's going to give me a lower number for this one. If I count this way, 2, 3, 4, it's going to be 1, 4. I want to go this way because it gives me a small number, 1, 2, 3. So obviously that's 4, 5, 6. But the important thing is 1 and 3. That's where my double bonds are. So it's going to be called 1, 3, 1, 3, cyclohexene. 1, 3. Oh, I should not be lazy, right? Hydrogen, 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 2 hydrogens, 2 hydrogens. Notice every time we put a double bond, we lose 2 hydrogens, right? Every carbon should have 4 bonds on it. Add hydrogens until you're full. So this is going to be C6H8. We lost the hydrogen on each of these to make a double bond. I'm not going to draw this one completely. I'm just going to draw the shell here, and we'll skip the hydrogens. But I want you guys to tell me what this would be called. Yeah, 1,2-cyclohexene. So it's still the same thing. It's still 6 carbons, so it's still hex. It's still in a circle, so it's still cyclo. There's double bonds, so it gets the ENE. But the important thing is 1 and 2. That's the position of these double bonds. Whereas this is 1,3-cyclohexene. So that's the difference there. All right. Let's do one more. So you don't have to write that one. This will be the last one. Draw this one though, because this one is a very common one, and it has a second name to it. It's not just a regular name. All right, and if you look at the carbons, the way I spaced out the double bonds, there's going to be 1 hydrogen on each one. Because every carbon has 1 double bond and 1 single bond, so it gets 1 hydrogen. And what's this one going to be called?
1,6-cyclohexene.
Okay, so let's go ahead and number the carbons. It's 1, 2, 3, 4, 5, 6. It'll be 1, 3, 5 actually. Each double bond starts with a 5. So if we go this way, 1, 3, and 5. At the beginning of each double bond. Cyclohexene. And the formula for this is just C6H6. 6 carbon, 6 nitrogen. And the common name for 1,3,5-cyclohexene, because you see it all the time, is benzene. Most people call it benzene, right? I think I asked you for that one on the worksheet. You'll see those hexene or hexane rings, hexene actually a lot, the bigger molecules will have them in them all the time. All right, questions on this stuff? If I give you, do I give them to you? No, I don't. There's no cycloalcohols on here. You would handle them the same way. If I said 1,3-cyclooctanol or something, you would just put oxygens on the 1 and 3 carbon. The same thing. You good? All right. I don't know what that means. Let me pass this out.
We'll take it from the vacation.